All right, welcome guys. My name is Liam. I am a undergrad here at UConn doing CSE. So I just finished my sophomore year, um, and yeah, that's about me. So today we're gonna be doing a lesson on Flappy Bird. It's like the block coding that you guys might have done yesterday. Um, Yeah, so we're gonna just learn some coding fundamentals through block coding, and let's get into it here. So, our objectives: learn programming principles through block coding. So we got module one, events and event handlers. And module two is going to be instances. Module three is going to be objects and sprites. Module four is going to be parameters and arguments. All right, so let's get going here. Module one. Is there no link? Oh, here we go. All right. Module one. This is what we're going to be going over. It's going to be events and event handlers. I think it's easier to understand this if you think about it in terms of the real world. So I think it's a little self-explanatory, right? You have an event and you have an event handler. A real life example of this would be you win something. That's the event that is occurring, right? The event handler is going to be the reaction to that event, right? So in the real life example where you win something, someone might celebrate as a reaction to that success, to the win, right? So you have your event, which is the win. You win something. You have your event handler, boom, that is you celebrating the win, right? So, in terms of programming, I would define it as the actual occurrences that are detected and responded to accordingly. So, maybe you're writing a program that wants to detect every time you click, right? So someone clicks a button, someone clicks a mouse, what are you going to do? You have to have an event to detect that, that's your event. You have someone clicking it. After that, you're going to have an event handler. What do you want to do when they click it? You know what I mean? So that's a better definition in terms of programming. The actual definition I had down there is code that is executed in response to a specific event, right? So you got your click, boom, event handler. All right, we want to make him jump. So every time he clicks, boom, we got to jump. That's your event and event handler. It's like a cause and effect relationship. That's like the best way to think about it. You have something happening, and because of this thing happening, you have this other thing happening, right? So I think that's probably the best way to help yourself wrap your brain around that. So to learn this, we can get going in here. You're gonna want to copy down this link, or you can just search code.org Flappy. It's gonna be the first thing that pops up. All right, that might be easier for you guys to do. Yeah, so once you're there, you're gonna see this. Everyone should be here. You're gonna have a introduction video. You can watch it if you want. Definitely couldn't hurt, but definitely not necessary either. So after that, you're gonna be here, and before you do this step, I want to go over a couple of things that I want you guys to think about when you're doing this code, right? So we have our step one focus. What is the event? What is the event handler? So when you're building these blocks, when it gives you these instructions, right? It says attach a block when click block. Oh, I read that wrong. No, I didn't. Oh, I did. Can't even do English here. Attach a block to the when click block. Then press run. Click or tap the screen to move Flappy to the target, right? So it's going to give you this set of instructions. Every time you do these instructions, I'm going to have a couple focal points that I want you guys to be thinking about when you're doing this. For this one, right? gonna come in here. This is what it wants you to do. It tells you exactly what it wants you to do, but I want you to think about it. Identify which one of these are the events and the event handlers. Think about the cause and effect relationship. So don't skip through this too fast. Really think about it. Think about, what is happening and then which one is happening because of something else. So I'm not gonna, is anyone on? No. So I'm not gonna wait here, but when you guys are watching this, I want you to pause the video real quick, think about that, do the process, really try and hammer in the definition into your mind. Think about, okay, what is an event? What is an event handler? Is this an event? Is this an event handler? And then come back to me when you guys are done and you think you have the answers to those questions. All right. So, assuming you paused, welcome back. You're probably going to end up, hopefully, with code like this. You can put the play wing sound in there. Doesn't really matter. Probably cooler to hear it though, but whatever. Now, if you guys said this was your event, the green when click, you were right because, oh, you know what? I might have given that one away in my example actually, but whatever. It is the action, right? If you think about it, not even because I told you the answer. If you think about it being like, okay, we have something happening, we have our click. Because of the click, we're going to have play wing sound, we're going to have flap. These are two event handlers. They are the reactions to the action, the cause and effect relationship kind of there, you know what I mean? So, that is that part. Let's see what happened on the slides here. So that's the code you're going to end up with. We saw that already. Our takeaways, we went over that. These are our two event handlers. This is the event. And these are, yeah. So I just want to reiterate though, it's the cause and effect relationship. So you have your cause, the click, it's the thing that's happening, the occurrence. You have your effect. These are going to be your event handlers, the things that are happening because of something else. And it's definitely much easier to think about it or understand how to program, how to solve these problems when you have the definition down rather than just memorizing, I don't know, my answer that I gave you guys by accident. So just keep that in the back of your mind when we're going through this one. All right, first step 2 here. Step 2, focus. What is the new event? What is the new event handler? So it's going to be the same question basically. Identify which one's the event, identify which one's the event handler. Just really think about, okay, what's happening here? And what is happening because of this occurrence, That's going to be your event handler, all right? So let's go over to the actual thing. Oh, I forgot to show you guys this, by the way. When you're actually done, you want to hit run. And you're going to just tap, right? When click, 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 it flaps. Boom. If you don't do it properly, right? Say I just have one click play wing sound. Reset, run, click, nothing's happening. I mean, obviously this one's pretty straightforward, right? But when you're programming in real life, you're gonna have a lot of error handling you're gonna have to do. So you're gonna have certain parts of your program that you're gonna test and say, hey, look, what if the user doesn't understand this and they do it wrong? We need to make sure our code doesn't break. So that's just something you want to keep in your mind if you're programming, right? You just want to make sure you have something to take care of all possible errors that could arise in your code. Cool. All right, so I want you guys to think about what is the new event handler, what is the new event. Pause this video, take a second to think about it, really like reiterate those definitions in your head. Think about the cause and effect relationship, and then come back, unpause the video, and we'll go over this one. Okay. Welcome back, everybody. Let me get to the actual step 2 here. Yay. We did it. Completed puzzle 1. Cool. That's what you're gonna get. So, for step 2, this is what you guys had. Now we've added some ground. Attach a block to the when hit the ground block. Your code needs to end game when Flappy crashes. Alright, guys, so if we think about this here, here's what I see when I'm thinking about it. You have your attach a block to the when hit ground block. When hit ground block, that just sounds like, okay, something is happening here. And we're attaching another block to this block, right? So you have, because of this block executing, this block is happening, you have another block happening. And if you think about it, it's like the cause and effect relationship again. So you have your cause and your effect. Boom. Cause is going to be if you said the event, you were right. It's going to be your cause is the event, and the effect is the event handler. So when you do that, when hit ground, we want to end the game, right? Boom. When click flap, of course, add in that play wing sound. Definitely sounds way cooler. And then we're going to come here and it's going to go boom, run, 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 flap. Oh, we hit the ground. What do you know? It ended because we have the event handler there. We have it saying, okay, when you accidentally mess up and you stop clicking and you hit the ground, you lose, unfortunately. All right, that is step 2. We went over all of this. Oh yeah, that's a good point. So notice all the compounding events and event handlers, right? So your code, this is just Flappy Bird. This is block coding. It's moderately simple, I would say, right? But when you're programming in real life, you're gonna have tons of different things happening. You're gonna have to take care of a bunch of things. You're gonna have a bunch of events and event handlers. This is really important in programming, and I just wanted to point that out to you guys. Like, in terms of real world examples, you're gonna have way more complicated programs where you're gonna have multiple events that you need to take care of and multiple event handlers. Right. Okay. So let's go to step. Oh, yeah, right. Module 1 summary. Cool. So this was events and event handlers. I just want to summarize this guy for you. So event, the actual occurrences that are detected and responded to accordingly. I think that's definitely not a bad definition, but to really like cement it in your head in the easiest fashion, I think it's the best to think about it as a cause and effect. You have your cause, the click, the effect, you flap. The cause, you hit the ground, the effect, you end the game. So I think that's just the best way to think about it. You have two situations, or you have a situation where you have something occurring, and because of this occurrence, you have to react to it. You know what I'm saying? So hopefully that makes more sense to you guys. And just another overall definition of it in terms of programming is when the game runs an event, will trigger a response from the event handler, right? So you got your event. It's going to say, oh, this event happened. We hit click, boom, flap. So cool. That is it for module 1. All right, so let's make sure. Oops, that's the wrong thing. Cool. Continue. Step 3. Before we go to step 3, let's move into module 2, instances. So, definition of instances. Every time you're running a program, that's a new instance of the program. You play Flappy Bird, or it doesn't even have to play Flappy or be Flappy Bird. You're playing a video game, right? Whatever you guys play, playing Fortnite. I don't know. I like playing Forza Horizon. If you guys are playing Forza Horizon, you know, every time you open up, that's going to be a new instance of the game. It's going to have your saved data. It's going to have all that stuff remembered, right? But every time that program restarts, that's a new version of the program. It's executing the code saying, okay, this player, he wants to play Forza Horizon. He wants to play Fortnite. We need to show the loading screen. We need to load in all the content, blah, blah, blah. That's going to be a completely new instance every single time you open the game. And this is really important because, people are going to be using your programs when you're writing them, right? So they use your program. What do? You have to make sure they have access to that. They can use it whenever it remembers their data, and it just executes when they want it to execute without being consistently on, right? Because we don't have unlimited resources like that. We can't have energy usage for infinite programs, So it's really important. And let's go learn some more about it in terms of Flappy Bird block coding. So we got step 3 focus here. There's going to be a block in the code. I want you to identify which block in the code is creating the new instance. So think about, all right, I'm running this program. What's going to be creating this new program? What's going to be resetting every single time? Yeah, think about that, right? So identify the new instance, and the other bullet is the set speed block an instance, event, or event handler? So this is a bit open-ended for you guys. I want you to look at the set speed block. Is it starting a new version of the program? Is it happening just as a user or something in the game? Is it happening, or is it a reaction to something else happening? Think about it like that. Remember the definitions we went over, right? So it's a cause and effect relationship for those events and event handlers. All right, so pause the video here real quick. Focus on these. Think about what the new instance is. Think about what thing the set speed block is, and come back when you have those answers. All right. So welcome back here. Let's go to step 3 solution. You know what? Let's actually run through this together. So the when run block allows you to run code when your game starts. Big hint here, guys, big hint. Try setting the level speed and flapping to target. Right. So first one was find the instance. If you guessed when run, you were right. If you guessed it because it was orange, that's smart, but I want you to think about, why is this the instance block? It's because you're running. This is the start of the entire program. When you run the whole program, this is going to create the new instance for you. It's going to set all the data. When run, we want this and this and this and this. Boom. Instance. Just really think about that. Try not to, finagle your way through these answers, because it's going to be easier for you in the future if you remember, hey, you know what, this is an event because it's causing something else. Oh, this is an event handler because an event occurred and now we're executing this part of the code, right? So just think about those definitions, really cement them in to make sure you're learning this stuff best way you can. Right. So when run, we want to set speed. That's what it's telling us here. You can set it to whatever you want. I'm probably gonna go normal because I'm terrible at this game. Just want to make it easy as possible for me. When click, we want flap, and you know what? Of course, we're gonna add in that play wing sound because it just sounds way better. Run, boom, and we hit the target. Boom. Awesome. So that was step 3. Nice. Let's see what the slides say here. If I missed anything. Oh, I did miss something. Completely missed the second question. My bad, guys. We got set speed block is actually an event handler, right? So it's a bit of a tricky question. This is it was a good test for you guys to think about, you know what, if you guys said when run is also an event, you were also right. Because it is an event technically, because when you're running it, this is an occurrence. It has a cause and effect reaction, you know? So when you're running it, you want to set the speed. That is an event. Setting the speed is the event handler. When running it is the actual occurrence. So that was a bit of like a 2-in-1 for you guys. It is an instance and an event actually. If you got that, good for you. That was really tricky because I completely forgot about that. So, and if you didn't, don't worry about it because that was super complicated and I completely forgot about that. Awesome. All right. Oh. Wait, Graham, is that still you on the stream or is that the school listening now? Because then I gotta make sure I'm not going too fast for these guys. I don't want to make them. I don't want to have to say I'm pausing the video if they can't pause it. Okay, never mind. So we're good. All right, cool. So that's step 3 solution. Next step. Here we go. Step 4 focus. What is being initialized as the instance is created? That's a new term for you guys. The definition, assigning something a value before we use it. So, you know, let's say we have a number or we have a variable, you know, we're doing, let's say x. We want x equal to 10. But later in the code, we have x plus 10. We can't do x plus 10 unless we know what x is, right? Because if you do x plus 10, that's not a number. It's not going to tell us anything. It's just x plus 10. But if we know x is 10, if you got 10 plus 10, you know that's 20. So basically, initializing it is just like declaring it before you execute it in code somewhere. So when you're going through, look for what is being initialized and identify the pattern between the green and blue blocks if you haven't already, because we went over that a little bit, but don't worry about it. Think about it. Which color is representing what here? You know, what's representing events versus event handlers versus instances. All right. Step 4 answers. Okay, set speed. All right. Let's go over this as well. I think it's better if we go through it together. So, Flappy will fly through obstacles unless you write code to make him crash. Attach a block to the when hit an obstacle block. Your code needs to end game when Flappy crashes into the first set of pipes. All right, let's fill this out first and then we can answer those questions. So, when run, set speed, boom, one click, flap, when hit obstacle. Oh, I can't actually speak English today. When hit an obstacle, end game. That's basically all you need. But of course, we're going to slap in that play wing sound because that's awesome. All right. This is what we got. Now, in terms of the questions I asked, what is being initialized when the instance is created? 1, we know the instance is the when run block, right? When run is when it's going to create all the stuff. It's going to say, okay, we're running the program. This guy wants to play Flappy Bird. He doesn't like any more Angry Birds. He wants to play Flappy Bird. We're going to have to set up all this stuff. Boom. We want to set speed to normal because he's bad. And he needs to have it normal. Then we got all this other stuff happening, but we'll talk about that in a sec. Basically, I just want to focus on set speed being normal, you know, we have to set that as the instance is created, saying create game, boom, set speed to normal. It's initialized as the instance is created. Cool. So in terms of correlation between the colors and the blocks, we got the green blocks are the events. If you said that, you were correct. If you didn't, don't worry about it. We're still learning here. That's what the whole thing is for. Blue blocks are going to be your event handlers. All right. So I don't really love that because I don't want you guys to think about, okay, green is the event, blue is the event handler. I just wanted you guys to recognize that these things are similar and they're compounding. And I just want you to make sure when you're doing these questions, you're thinking about, okay, this is an event because it's an occurrence. This is an event handler because it's the reaction to this occurrence. All right, yeah, so cool. Just want to reiterate that. That is step 4. If we do this, we can try. Boom, boom, boom. Oh, I hit the block. I didn't even mean to, honestly. I'm just pretty bad. Let's replay it, actually. So if we replay it, and I'm actually good, what you can see is if you don't hit the block, oh my god, I'm actually terrible. But you saw it, I almost got through there. If you don't hit the block, it keeps going, just like our program said, so that's cool. And we'll see how this evolves in the next coming steps. All right, step 4, went over that. Cool. Module 2 summary. Bam. So in this module, we went over instances. Instance, the realization of any program or component within that program. That is just a super complicated way of saying, all right, someone wants to play this game. We got the game. We got to start it up, set up everything for this player, make sure he can play this whenever he wants, and make sure it's not running all the time. Initialization, that was a little side thing we added in there, right? So declaring values in the code before it's actually used. That's just key. It's if you think about it logically, right? You know, if you want to use something, but it's not there yet, how can you possibly use it? If we wanted to use the x plus 10, but x doesn't, we don't know x, how can we possibly use x plus 10? We just can't, right? So it's really important to think about, hey, I want to do this. I got to make sure I have all this, boom, 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 set up before I can do that to make sure everything's good and there won't be an error and break my code, right? Yeah, and also you can initialize values anytime in the code as long as you're using them after you initialize them, right? I don't want you to think it's only when you create the instance. And you're definitely initializing a lot of things when you create the instance, right? Because you have to set up so many different things for the program. But you can do it later in the game for sure. It doesn't really matter as long as you do it before it's executed in the code. That's the important part. All right, let's move on to Module 3. Module 3, Objects, Sprites. Okay, you guys kind of went over this yesterday, I think. Unless you didn't, maybe you watched the YouTube video. Unless you didn't, and we're going to be learning about it either way. So, an object is a fundamental building block in programming. It represents a specific entity encapsulating some data. And that is just a little confusing technical definition of it. It's basically just like just the character, something in the program that you can use. Let's say x equals 10, that's actually an object. It's a little hard to wrap your head around because you're used to saying, oh, an object is this physical entity. Is this phone, this is an object, right? But in programming, we have virtual objects which we define, which we initialize, which we just learned about, right? And yeah, I think it's going to help you understand it once we go in and learn, you know, what it is in terms of Flappy Bird block coding terminology. And a sprite is a version of an object, right? It's just in video games. They're used to represent the characters and interactable features. All right, so that would definitely confuse me if I was just learning. So let's get started, and I'm sure it's going to be much less confusing once we go through all this stuff. All right, so in step 5, we're going to focus on what objects can you identify. Okay, so think about, it doesn't have to be an entire block. It could be a part of a block. It could be multiple blocks. It could be anything in the game that you can think of is, okay, we define this. We say this is equal to this. We have this specific entity, right? Just think about it that way. It's a bit confusing. We'll go over it, don't worry. And then after that, we'll be pros. So it's great. Do any of the objects have values in terms of numerical value, or I think only numerical value we're gonna look for here, but I might be wrong, so I apologize if I'm wrong, but we'll see. So pause the video here, think about what object can you identify, and do any of these objects have numerical values? Maybe they have different values. Maybe you're smarter than me and you actually see something I didn't see. So go and try and outsmart me, pause the video, come back when you guys do that step, answer these questions, and we'll see how it goes from there. All right, welcome back. I'm assuming you guys did this and everyone outsmarted me, and let's see if you're true or right. Man, I cannot speak English today. Cool. Completed puzzle 4. Puzzle 5. Here we go. Add a scoreboard. Okay. So let's add a scoreboard and count the points when Flappy makes it past obstacles. Add to the when past an obstacle block, and then score a point by flying Flappy through the first set of pipes. All right. We got when run, set speed, boom. When past obstacle. What do we want to do? Oh, end game. Okay. Let's run. Let's test this out. Wow, I'm actually terrible. Okay, I'm actually terrible at this game. But I wanted to show you guys the error right there, right? So let's say someone is using the game wrong. You know, you don't have this error handling here. Maybe you made a mistake in your code. It's gonna happen. Someone's gonna try and play Flappy Bird. They're gonna think they're so good, they get through the pipe, boom, game over. They're gonna rage quit. So just want to reiterate that error handling stuff again, right? So you're gonna have a bunch of components in your code. You're gonna have a bunch of stuff to talk about, and you're gonna have to make sure you're focusing on, you know, every little possible detail of error. Where could this go wrong? How could the user mess this up? How could I mess this up? And make sure you handle all of those cases. But if you actually read the prompt properly, you would see that it says when you pass an obstacle, you want to score a point, right? So when click flap, of course, almost forgot the wing sound there. Can't forget the wing sound. When run, set speed, got it. When pass obstacle, score a point. Boom. Let's reset this. Let's try this again. Click, 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 click. All right, let's see if I can do this. Oh, okay. Well, I guess they counted that as going through the obstacle. It's good enough for me. I probably wouldn't have gone through anyways. Nice. All right, so let's focus on the objectives from that. Objects. The objects in there were speed, obstacles, score counter, and the bird. Oh, I can't see my hand. I was counting with my fingers, but whatever. All right, so your speed is that you're gonna set it, right? Let's say you're creating the game. You create your instance of the game. What are you gonna do? You're gonna set the speed. Speed is equal to normal. That is a value. That's an object that you're gonna keep and make sure you have, I don't know, I guess you can change it in this game, right? But you're gonna be setting it up and you're gonna say, okay, blah 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 is equal to blah blah blah. That's actually a that's a good way to think about it, right? If you can say this value, or not value, let's say you have speed, right? Let's say you have speed is equal to something else. That's a great indicator of speed being an object. If you have something equal to something else, maybe it's not a numerical value, maybe it's normal, because normal, it's the speed you want to go at. Yeah, that's gonna be an object for you. So just think about, okay, is this equal to something else? Obstacles, those were objects because they're interactable features in the game, right? So we talked about that. You know, when you hit the obstacle, something happens. But how are you going to detect if you hit the obstacle? The obstacle has to be an entity within the game that you can detect and say, okay, we hit the obstacle and the game is over now. Score counter and bird. Bird, same thing, right? It's a physical entity within the game. How are we going to see if the bird passed the obstacle? How are we going to see if the bird hit the obstacle? We need to know when those two are coming in contact or not coming in contact, whether or not to end the game, to know whether or not to end the game or to give them a point, right? So, speed and score are both record numerical values. Cool. So, I guess speed could also be a numerical value, right? If you set, let's say you have 5 being normal, and then you have a range of 1 to 10 as you set the speeds. And that's how you do it. But you can also have it as the word normal. Could be either one, as long as you're having speed is equal to this other thing, right? And score, you know, we have score. We got to keep track of the score. You know, if you're going through, you got 0, 1, 2, 3, getting up there. Probably will never get past 3. But, you know, if you're getting up there, you got to count the score. You're coming in, you got to say, okay, I have score equal to 0, passes obstacle. Score equal to 1, passes another obstacle. Score equal to 2, hit obstacle. Score, reset, go to 0, right? So just think about it. This, you got something is equal to something else. Cool. Let's go to step 6. Step 6, focus. Which ones are just objects and which ones are sprites? Recall the difference between both of them. I won't make you go all the way back in the video, but basically, objects, or actually there's a better way, I think. Sprites are objects, right? So identify all objects, then you have all the objects. Then you go through all the objects. Sprites are objects that are playable characters or interactable features. I think that was the exact definition. But either way, that's basically what they are. So think about it. You're going through all your objects. You have a list. Is this object a character or an interactable feature? If yes, sprite. Cool. So pause the video. Go to step 6. Identify all objects. After you identify all objects, go through. Ask yourself, is this a sprite or object? Why or why not? I need you guys to really reason yourself through these questions, right? So you cement the idea and understanding inside of you. Okay. So pause this video, and then we'll come back and we'll talk about the answers. Okay. Welcome back. And let's go over the answers here. All right, let's do this step. See if you can still score a point after making Flappy flap either a smaller or larger amount. When click, oh, they have score a point. Flap a normal amount. All right, so they're trying to get us to switch it up. Let's go random. I don't even want to know. I'm actually a pro. I was lying to you guys the whole time. Let's see. We come in here. What do we got? Oh man, that's pretty flappy. No, I'm a pro actually. That was right in the center, if you can see that. Yeah, that's perfect. Okay. That is the step. That's not a big step. I think the focus there was to identify all the objects and sprites. So, if I hit replay here, let's go through. When run, is this an object, yes or no? You said no, because it's not an object. Good call. Set speed, is this an object, yes or no? And you said no. Jokes. It was an object. I said that in the last one. I don't know if you guys remember. Right, we're setting speed to normal. We can set it to other things. Very slow, blah, 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 random, all these things, right? So, yeah. Make sure, sorry, lost my train of thought there, guys. Yeah, so we can set this speed. So we have speed is equal to something else. That is an object. Now the question is this a sprite? And you said no. Correct. Because is this a character? Is this an interactable feature? No. I could see how you might get confused saying this is an interactable feature, right? Because you can change the speed. But when I say interactable feature, I'm talking about in the game here. I'm talking about things that are actually, happening, that are interacting with each other within the game, not outside of the game in the code we're doing, right? Okay. Let's move on here. We got the when click block. Is this an object? And you said no, which is correct. Flap a random amount. This is not entirely an object, but flap itself is an object. I guess you could say we're initializing an object here, where we have all these options and we have flap. Flap is going to be kind of like speed. Flap is equal to what? Flap is equal to random. Okay? So just think about that again when you're thinking about, okay, is this an object? What is this? Is this equal to this? Can I say this is equal to something? Okay. Now, is this a sprite? And the answer to that question is no. It's not a sprite because it's not, again, not an interactable feature. Are we seeing flap interact with any of these things in the game? No, it's just something that's happening. So that brings us to the last thing here. When pass obstacle. This is an event, but in the event, it is mentioning an object, and that object is an obstacle, right? So the obstacle is the game, or oh my god, the obstacle is an object in the game, right? And I guess you would probably say it's an interactable feature because you're coming in here and you're saying, all right, we got the obstacle, we got Flappy Bird. These two things are interacting within the game. When Flappy comes in contact with the obstacle, end game. When Flappy passes the obstacle, give him a point. Right? So this one is actually going to be a sprite. Cool. And I just wanted to also mention Flappy Bird itself is a sprite. It wasn't exactly mentioned in the code, right? But it's interacting with the obstacle, just like the obstacle is interacting with it. It's they only work with each other. So they both need each other to work, and I guess by that logic, that reasoning, you can say, yeah, both of these are sprites because we need them to both be happening or both be there for things to occur. All right, let's get moving to step 7. Let's see if I miss anything. Nope, we talked about all that stuff, but yeah, we talked about all that stuff. Cool. Step 7, focus. what new feature is being initialized? So we're talking about initialization again. Think about what's being set. What's being set equal what's being initialized, what's being created for the first time. Okay. And then what new object is being added? I want you guys to identify these two things in step 7. So pause the video here. Go identify these two things, come back with your answers, and we will review them. Cool. All right, guys. Welcome back. Step 7. Oops. Skip too far there. Here we go. Step 7. The new feature was set scene initialized when the game is run. And remember, it doesn't have to be when the game is run. It doesn't have to be when the program is started. It has to just happen before you use that value. All right. And the new object is ground. Okay. The ground is actually a sprite because it is a interactable feature. You know, you got your Flappy Bird. If Flappy Bird is hitting the ground and nothing happens, no one's gonna play that. It's too easy. You want to make sure they got a challenge, right? So we got when you hit the ground, that's game over. Yeah. So those are your two new objects, or there's your new object, new sprite, and then the new feature, set scene is being initialized there. And this is what your code should look like. We can build it together if you guys want. If not, feel free to skip this part. Just want to make sure you got win past obstacle. Oh yeah, forgot I hit replay. Let me reset this and get to the right step. Let's see if I can get 2 in a row here, guys. Man, this is going slow. There's a high probability I don't get this. Oh, we messed up. That's brutal. Let's retry. I guess I couldn't get 2 in a row here. Why is it going so slow? Oh, silly me. This is exactly... All right, that's actually a good example. So when you're coding, sometimes you're just not thinking. And you're like me and you set speed to super slow and you're like, why is the speed so slow? Probably because you set it to super slow, right? So just keep that in the back of your head when you guys are programming, you know. Maybe you think, okay, I know exactly what I did. There's no way this is the error. That's almost always where the error is. Make sure you go through, check all of your code. You know, when I'm programming and I find an error, it's most of the time because I try to run my program and it doesn't work and I'm like, okay, I know where this is. And I go look there, not even close to that spot in the code. So you got to look everywhere. Think about, okay, where do I think this error could be? And then think, where do I not think this error could be? And definitely check there because, you know, it happens all the time. All right, let's try this for real this time. Let's see if I can get through here. Boom. Completed puzzle 7. Let's move to 6. Man, I can't count, read, talk. Brutal here. All right. Next. Okay, yeah, cool. When run, set speed, got that. When click, flap a normal amount, that's good. When hit the ground, end game. When hit obstacle, end game. When pass obstacle, score point. That sounds good. Let's get that play wing sound in there. Awesome. Let's hit run. Let's click. I'm bad. Oh, I hit the ground. That's good. We want our program to do that. Let's make sure everything's working. We got to test our code, right? So I didn't even mean to do that, guys. I'm actually terrible at this game. Let's see when you hit the pipe. Game over. That's good. Let's see if I can do this, guys. And I got one. I'll take it. That's actually not bad. Got one. Um, that's kind of like real life though, right? So you have all these cases where maybe the player isn't getting through the obstacle. What do you do then? You got to end the game. You got to do whatever it is that your program needs to do. So you got to test it. You got to make sure it's actually doing that, right? Because if people are going right through the pipe, if people are just hitting the ground and not ending the game, that's not Flappy Bird. That's not what we wanted. So you got to make sure you're testing all that stuff very thorough. It's a big part of software development is just thorough, constant testing. Cool. Now, move on. We got Module 3 summary, guys. So we just finished 75% of this. Let's summarize it here. An object is a fundamental building block in programming that represents a specific entity encapsulating some data, right? That was a super confusing technical definition of an object. The way I want you guys to think about it is something equal to something else. X equals 10. Speed equals normal. Flap equals random. Right? That's how you're going to identify your objects. In terms of sprites, it's harder to identify them with that kind of mindset, right? For sprites, I want you guys to think about, is this a playable character? Is this an interactable feature? Are the player or the characters interacting with this thing? Are they interacting? Maybe it's a sword in a game. Maybe in Fortnite, I don't know. You run into a tree. Can't go through the tree. Gonna mine it. Those are all sprites because they're interactable features within the game. But you got to remember they're also objects because you have to define them. They're just a specific version of objects. Cool. Awesome. Let's continue here. We got module 4. Let's do this. Arguments and parameters. All right. Arguments and parameters. We got arguments are the actual values passed into the function when it's called, while parameters are the variables defined in the function's declaration that receives the values. Super complicated, right? It's good to know the technical definitions. Definitely very good to know. But when you're just learning, I think it's easier to understand things in simpler ways. So we have a function. Our function, don't think about it like a math function. Think about it just like, I guess, something's happening. We have this function that says, I want to add 10. I want to add 10 to x. So we're going to say, here, function, we're going to give you x, right? It's going to add 10 to x, and it's going to return it and send us, here's what the value of x plus 10 was. The difference between arguments and parameters is when you define that function, say, we call it calculate. Say we call it calculate, right? So we got a, we're going to pass, we're going to give x. We're going to give x to function, calculate. That x we give to it, that x is actually going to be the argument, right? That's something we define. We say, all right, x is equal to 10. X is an object. We're going to pass it in. We're going to give it to calculate. Calculate's going to say, all right, you got this number. I'm going to add 10 to it, and I'm going to give you it back. The parameters, that is what you use when you actually define it. So when you say, I'm going to create this function, and I want people to give me x, I want people to give me a object, a variable. You don't define it. You don't say x is 10. You don't say x is anything. You're just saying, in order for me to work, I need x. Right? So parameters are going to be what the function needs to work. Arguments are going to be what's given to the function in order for it to work. And we're going to see this And it's going to be explained much better in the modules. And then we'll be pros after again. We're going to be programming pros after this whole thing. Step 8, focus. Identify all arguments and parameters. And I want you to identify, are they arguments or parameters? So identify every one of them and then identify which one of them they are. All right, let's do this. I'm going to go into the actual code and run you guys through this because it's much better that way. Not quite, you have used the block, you aren't using it. What? My bad, guys. Am I actually this bad at block coding? Oh. Reset. All right. Cool. Step 8. Let's run through this together. Bit complicated here, right? First, I'll just tell you guys straight out. This set speed. These are both going to be arguments. We have a function that's going to set the speed for us. Okay? We have a function that's going to set the flap amount for us. These functions are already defined. They're saying we want a variable telling us how fast or how much flap. Okay? And that means that they already have the parameters. What we need is to give them the arguments. Does that make sense? So, let's go to slide. Maybe, okay. Any block with an adjustable value is a block that accepts arguments parameters, which is not true actually because they are only arguments. Oh, okay. Guys, I totally lied to you. Disregard everything I just said. Yeah, so you know what? This is even complicated for me, so don't feel bad if you're not getting this right now because I even had to read my own slides again to learn what I was thinking the first time. All right, so let's go back. So let's go think about these slides. Any block with an adjustable value is a block that accepts those arguments / parameters. Okay? There are arguments if you look at it from the game's perspective. But if we're the users, right, we're passing in these values, so they are parameters. A better way to explain this is we have these 4 things, right? These are all adjustable values. Each of these 4 things, they have values that they're getting passed in, right? As the user, we are the ones passing it in. We are giving them the parameters. We're telling it, this is what we want the speed. This is what we want to be our player. This is the time of day. This is the flap amount. We're giving it the parameters. What I meant by, if we look at it from the game's perspective, is that's the function, right? They're defining the function as setting the speed, set player, set scene, and flap amount. Okay, we have these 4 functions. We're defining it, and we're saying we need this value. We need you to give us a speed. We need you to give us a player. We need you to give us a scene and a flap amount. It's looking for those arguments. In order for it to work, it needs those arguments. Yeah. Yeah, cool. So yeah, just think about that, right? So you have, there's two different ways you can think about it. If we are giving it the values, we're giving it parameters. If we're defining values, we are giving it arguments, right? So that was a super tricky one, guys. Do not worry if you were confused on that because I even got confused. So let us both learn together, or all learn together, in this next step where we will talk about what a block represents, what component we have gone over so far. Right. All right, so this one, actually is going to be a huge summary of everything we've done so far. We've gone over events, event handlers, instances, and arguments and parameters, and objects and sprites. I almost forgot about that. We've done so much today. I want you guys to go every single block. Look at the block. Is this blah, blah, blah? Why is this blah, blah, blah? Think about the definition. Oh, this is something's happening here. We have an event. Oh, what do we know? Blah, 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 blah. I don't want to give you guys too many answers, but I want you guys to really actually go through. Maybe not every block, but really solidify your understanding of these blocks, these principles of programming, right? So you guys can just look at it and be like, bam, this is an object. Bam, event. Bam, event handler. Bam. You know, if you guys have it cemented off the top of your head, it just comes so easy. All right, so pause the video here. Oh, don't look at that. That's cheating. Pause the video here. Go look at all those. And then come back when you're done and we'll review it. Okay. Here are the answers. One run. We went over that, right? Maybe you didn't remember it. Maybe you had to reason yourself through it. When you run the program, you're initializing it. You're creating the new program, right? So that is going to be your instance. That's going to be every time you want to play the game. Boom, run. Cool. Set speed. It is a function with parameters and arguments that initializes an object. That one is super confusing, right? That was a trick question. If you guys got that, bravo. That was super confusing. You have a set speed function, right? Set speed says, okay, here's what I'm going to do. You got a game, you got a Flappy Bird, I'm going to tell it how fast to go. I need the user to tell me how fast you want it to go. And I'll set it up. I'll do all the work. You just need to tell me what to do. We pass in, man, these arguments and parameters got me stumped. Right. We pass in the parameters. What does it do? It takes that value. It sets speed equal to whatever we pass in. All right. So we're going to have, I don't know. What do we have? We had normal, super slow. Yeah, let's do super slow. Say we got, all right, I want to play super slow. I want to do it super hard. It's going to make it very interesting. I'll probably never get a single obstacle. What are we going to do? We're going to say, hey, set speed function. We want it super slow. Set speed function says, all right, that's cool. I'm going to take this value. I'm going to have set speed equal to super slow. And then that is how that works. That's a bit of a compound answer right there. So don't worry if you didn't get that. That was super complicated, but I just want you guys to understand, you know, these aren't always occurring in individual segments, right? These aren't just like individual blocks executing at their own separate times. It gets complicated when you're programming. You have all these different kind of principles nested together, and that's why it's so important to understand each of them individually so we can understand how they connect together. All right? All the green ones, those are the events. Don't think about it like that, though, because when you went through it, because I know you all did, and you went, oh, this one, something's happening, and we got something happening because of it. I know this is an event. I know that because I learned it like 30, 40 minutes ago. We got the teal, blue, green ones. I don't know what color it was. Whatever works for you guys. These are the ones that are the event handlers. This is happening because of the event. So this is definitely easier to identify if you have already identified the events. But if you haven't, we go in, we say, okay, this is happening. Why is this happening? Oh, because of something else? We know that's an event handler. It's handling an event. Something occurred. We got to click. What are we doing? Because of that click, we're going to flap. Boom. Event handler off the top of our head. Awesome. Next, we got objects. speed setting, score counter. We went over those. If you don't remember them, we thought about it. We said, we're setting something equal here. We got speed equal to this. We got score equal to this. That's how we remembered the objects. And finally, we got sprites. All right. We got the obstacle and bird. We went over that as well. But if you don't remember it, or you just wanted to practice and really solidify those ideas, we said, oh, these two things are interacting. They can't happen without each other. These are parts of the program that they're almost physical entities of the program that are interacting, right? So I think that's the best way to think about it. You know, you have an object, it's a thing in the game, right? It's a thing in the game. But it's not an object because Flappy Bird isn't equal to something. You know what I mean? So you're like, oh, what am I doing here? Oh, well, Flappy Bird is interacting with the obstacles. Flappy Bird is interacting with the ground. Oh, what does that mean? It means we got a sprite, you know? So I think that's the best way to think about that. Let's go. Final step here. Whatever you want. So we basically learned about everything we learned or needed to learn today. This last step is for you guys. Just want you guys to play around, have some fun with it, and think about, you know, when you're playing around with the game. You know, we're playing Flappy game. It's pretty cool. It's fun. I mean, I used to play Flappy Bird all the time. I was probably better than I am now because I'm kind of actually garbage here, but whatever. When you're playing it, think about, hey, I'm building this new feature. I'm doing this new thing on Flappy Bird. I'm doing this and that and that. Oh, what is this actually? What is this in terms of programming languages? Like, oh, I want to create a new object. I'm doing this new object here. Oh, I got this new event handler because when this happens, I want this to happen. When you guys are building that, just think about it like, wow, imagine I was building a real program like this. What if something else happens? What if my friend uses it and he doesn't use it like I thought he was going to use it and he breaks it? You got to have an event handler for that. Have some error handling, right? Think about it, make it cool, have fun with it, and pause the video for now. Play around with it, do whatever you want. And when you guys are ready to go over Module 4 summary, just come back, unpause the video, and we're going to do that. All right. Module 4 summary, arguments and parameters. Guys, this one was super confusing because they're pretty similar, right? Even I had a hard time remembering which one's which. Couldn't wrap my head around it until I just thought about it. You know, you have arguments. Those are the values that are actually passed in when you have a function. You're saying, all right, function, here, take this value. That's my argument. And when you're defining the function, you have values that say, hey, I'm a function, but I can't work unless I have this value. I need you guys to give me this value. Those are gonna be your parameters. No way, did I just mess that up again? No, I did. All right, cool. That would have sucked. But a little embarrassing right there. Oh yeah, right. So in real programming, we're not just setting them, initializing them, and then playing Flappy Bird, right? We have functions happening all the time. We have them executing multiple times within a specific program. We have them changing all the time. We have the different arguments changing all the time. So I don't want you guys to think of this as like some sort of plain view. Okay, we have speed and we set it one time and it's done. What if you're setting speed? You have not speed, score. You're setting a score, right? During the game, you come in, he starts at 0. You got a function, says, this guy's at 0, we pass in 0. Yeah, cool. Now, what do? You got score, he gets through the obstacle, you got score +1, pass it to score, to the function score. It says, all right, cool. We're on the move, we're in the middle of the program, doesn't matter. We're going to add 1 to his score because he's doing so good. And then that's how you're kind of working with functions dynamically to make sure your program can run and execute these things concurrently with the user, right? You don't want someone playing Flappy Bird and they can't count the score. How are people going to know I got to 4 billion, which is the world record in the Guinness World Record book? Cool. Key points. All right, this is a big summary of everything. It's a lot of words on the page. So let me just summarize this for you guys. An instance, that's what we learned today. It's a specific version of the entire program being run. So every time you're running Flappy Bird or, you know, big Fortnite guy, every time I'm running Fortnite, that's a new instance of Fortnite. It's got all my data, right? I'm not saying it's different data and stuff, but it's a new instance of that program. It's saying this guy wants to play Fortnite. All right, let's boot this up for him. Let's set up all this stuff, and here we go. He can play Fortnite. We got sprites and objects. That's a character or a thing in your game. Flappy Bird, Mario, Renegade Raider. Those are sprites, and we learned that objects are defined as something equal to something else. That's the best way to remember it for me. And then we got events. Events are something that's occurring. You got your click. What you're gonna do when you click, you got your flap, and the flap is the event handler. You're right, correct answer. Awesome, you guys are pros. And then we got arguments / parameters. So this is definitely the confusing one. I would definitely think about this one a lot. Maybe go over that module again, try those steps again, because this one was pretty complicated. When an event is triggered, you know, when you pass obstacle, right? That's an event. It triggers the add 1 or the counter to the score. What happens is you have the information passed into the code. You get your argument passed in to the preset parameters. Parameters are what you have when you create the function. You create the function, you say, we need this. This is your parameter. Oh, you need this? All right, I have an argument for you. This is what we're passing in. Here, take this. Yeah, that might just have to be like a memorization kind of one. But definitely remember that, because that is going to be all over when you're programming. I don't think I've ever actually wrote a single piece of code that hasn't required some sort of function declaration or some sort of arguments or parameters being passed in. So yeah, definitely getting knowledgeable about this. And I have a little code challenge example. Just want to go over this really quick with you guys, because I think it's more interesting to learn about actual code than some block code, but it's really important to get these fundamentals down before we get into the code. Just want to run this through real quick. This is our function. We're defining it. Function's called introduction. What are these? Boom, boom. Those are our parameters. We're defining them in our function. We're saying we need value 1 and we need value 2. What are we going to do when we get these? We're going to give them back. We're going to add them together. So we need these to be numbers. Don't worry about this stuff. This is just a bunch of Python syntax language stuff. This we'll probably go over at some point, or in a different module, or just throw a question in the chat. We'll have some answers for you, you know. But anyways, here we go. We got the user gives us 1 value. The user gives us 2 values. These are our arguments, right? It says, all right, I want to know what the addition of these 2 numbers is. I say, I got a function for you. I can do this, but I need value 1 and I need value 2. And you say, all right, I got value 1, I got value 2. Here they are. What are we going to do? We give them, we pass them in here. This is introduction, is our function. We pass it in here, and yeah, these are arguments. What does it do? It comes in here, it says, all right, we got value 1, value 2. Add them together, returns it. What's this going to do when we have a function like this? It's going to give us a number. We're going to print out the number. Here's an example. We got value 1, 4. We got value 2, 5. Let's say you didn't know that because you're really tired. You just woke up in the morning. You don't want to do 4 plus 5. That sucks. What do? You go, hey, introduction. I got 2 numbers for you. I need you to add this. what does it do? Boom, 4 plus 5 equals 9. That's kind of how the function works there. So maybe this helps you guys understand a bit better the difference between arguments and parameters. And if you guys are interested in learning more about Python, or have any questions about any of the stuff I did here today, feel free to throw questions in the chat. We're here to help. We're here to help you learn, because I was here at one point. I was learning. I didn't know anything, and it was a bit overwhelming, to be honest. So if you guys have any questions, anything at all, even about UConn, maybe not even about computer science or whatever, feel free to reach out to us. Yeah, we're here to help. Cool. Thank you guys for watching this. And I hope you guys learn a lot. Thank you so much.
This program was made possible through generous funding from the National Telecommunications and Information Administration of the U.S. Department of Commerce.